All right, let's go and get started with a speed drill today. Speed drill 18. Speed drill 18. So if you turn to, I believe it's page plus you 17 in your speed drill and review exercise booklet. Try page 18. Speed drill 18 on page 18. That works great. And you are practicing multiplying signed numbers. So it's a multiplication box, but you're doing with signed numbers. Now, that shouldn't be bad if you remember two rules. If the signs are the same, you automatically get a positive. And if the signs are different, you automatically get a negative. So it really shouldn't be that hard, but you get a whole extra minute to help think through that. You get 3 minutes instead of 2 on this multiplication box, and you may begin. Glenn, do you need to visit the library today? Make sure you're working on something, Glenn. Instead of just scribbling. One more minute. Stop. Go and put your pencils away. Take pens out. Pencils away. You finished just in time? Awesome. All right, pencils away, pens out, and exchange so that you do not have your own. So pencils away, pens out. Exchange amongst yourselves so you don't wind up with your own. And if you would, in pen, sign your name at the bottom as the grader. In pen, sign your name at the bottom as the grader. These are 2 points each. 2 points each. What I'll have you do, just as a reminder, because it's been a little while since we had one of these boxes, at the end of each row, write the number incorrect. Okay, so we'll go across the row. Again, if the sign is wrong, it is wrong, right? For instance, if I think I have $30 in my bank account, but I have negative 30, that's a big difference. One, I can take my wife out for dinner. Not anywhere real expensive, but I can take her out. The other, we had too many dinners, okay? And so a big difference, right? So yes, if the sign is wrong, it is just wrong. Going across the top row, here we go. Negative 48, positive 32. If they had just 32, remember that's the same thing. A positive sign doesn't have to be written. Negative 64, negative 24, 0, 72 or positive 72, negative 96, negative 16, positive 40, negative 80. Go put the total number wrong at the end of the row, hopefully minus 0, and let's go to the next row. Negative 36, positive 24, negative 48, negative 18, 0, positive 54, negative 72, negative 12, positive 30, negative 60. Next row, positive 42, negative 28, positive 56, positive 21, 0, negative 63, positive 84, positive 14, negative 35, positive 70. Next row, row number 4, negative 72, positive 48, negative 96, negative 36, 0, positive 108, negative 144, negative 24, positive 60, negative 120. And the last row going across, positive 54, negative 36, positive 72, positive 27, 0, negative 81, positive 108, positive 18, negative 45, positive 90. Figure the total number wrong, times 2, subtract from 100, and put the score on the score page next to where it says Speed Drill 18. Speed Drill 18. And return to the owner. Making a lot of multitask here in the middle, handing them back and forth, giving her a workout. All right, any hundreds? You got every one of them correct. All of you, fantastic job. Let me go and collect those from you, and if you would, take your homework out, turn your textbooks to page 379. Page 379. On page 379, you did numbers 1 through 12 for homework last night. Page 379, homework, numbers 1 through 12. And yesterday, we moved off of probability in the simpler sense and began talking about the number of ways in which items could be arranged. And we said if you wanted to take the number of different ways in which items could be arranged, there's a term for that. It's kind of a funny word that starts with a P. Remember from yesterday, the number of ways in which objects could be arranged.
Permutation.
Permutation. Okay, a permutation refers to the number of ways in which something could be rearranged. But we said this, that if you take a permutation of every single item, and you're going to use all the items, then really all you're doing is taking the number of items times 1 less, times 1 less, times 1 less, until eventually you get down to 1. That's referred to, Scott, as a close. Factorial. How do I represent factorial algebraically? Good, with an exclamation mark after. And you practiced with basic factorials yesterday because in every one of our permutations, here was the key, you were using everything that was there. The farmer had 6 different types of vegetables. He put all 6 vegetables on the cart. Today we're going to look at, well, what if he doesn't put all of them on the cart? What if he only takes 4 of them at random? Now how many ways could you arrange this? We're going to look at that more today. But for now, we're going to practice with basic factorials. And the first 3, you were just writing them as factorials. Number 1 should have had 7 with an exclamation point. Number 2 should have had 4 with an exclamation point. Number 3 should have had 6 with an exclamation point. I assume we got all of those right. Good. All right, we move on. Number 4, 5, and 6, you were finding the value of each factorial. And what is the value of 5 factorial, Scott? 120. What about the value of 7 factorial? Joshua?
5,040.
5,040. And then 3 factorial, Lana, is simply
6.
6. Did we get all of those correct? 4, 5, and 6. Excellent. Number 7, for each expression, or for each situation, express using a factorial and solve. Number 7, Billy recorded 6 different Saturday morning cartoons so he could sleep in. In how many possible orders could he watch his recordings? How do we represent this first of all, Lana?
6 exclamation point.
Good, 6 factorial, 6 with the exclamation point. And how many different ways could he watch his recordings?
720.
720. Number 8, a website uses a program to generate user IDs. How many 10-digit user IDs are there when each of the 10 possible Arabic numerals is used only once? Now, reality, you should be able to reuse, right? But if you don't, for instance, if there's a 9 somewhere, there's not another 9 later. So each of the 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is used one time. How many different ways could we, how many different user IDs could be generated, Scott? 10 factorial, 10 exclamation point, and how much is that? 3,628,800. Do we do the multiplication correctly?
I have that as my answer, but then I accident, when I worked it out, but then I put an extra 0.
Put an extra 0 by accident.
Oh, yeah.
All right. Questions on that? Now the numbers 9 through 12, just basic practicing with fractions. Number 9, by the way, all of these are addition or subtraction. So if you want to add or subtract fractions, class, you have to have a common denominator. So on number 9, what was your common denominator, Josh?
40.
40, and your answer?
31 over 40.
31 over 40. Number 10, what was your common denominator, Lana?
18.
Okay, you could have used 18. I would have used 6, but you could have used 18. Same answer either way. You get?
1/2.
1/2. Number 11, Scott, common denominator?
21.
21, and your answer?
19 over 21.
19 over 21. And the number 12, Josh, with a common denominator?
8.
8. You could have also used 16 or 32 or any of those, but 8's the best one. And what did you get for your answer?
1/8.
1/8 is correct. Questions on any of those? I thought I saw a look of...
For some reason on number 11, I had 16 over 20.
When you multiplied the first fraction 1/3, top and bottom, by 7, did you get 7 21st? And the next one, where you had 4 7s, you multiplied top and bottom by 3. Did that give you 12 21st? And then that would have given you 19 21st for your answer. Questions? All right. Any questions at all on those addition, subtraction, fraction problems? All right. Well, as I mentioned, let's talk now about permutations when not all objects are used. For instance, let's suppose, because our class is very small, let's suppose that all of you were to stay here all the way through graduation, which is certainly what we would love to have happen, and we were to add, let's just say, 5 more students to the class. Okay, there's only 3 of us right now. If we added 5 more by graduation, that would give us a total of 8. Now, of those 8 students, at graduation, 1 person would be called the valedictorian. That's the top dog in the class. 1 person would be named salutatorian. So there are 2 people out of the 8 who will receive those highest honors at graduation, right? Well, of the valedictorian, how many possible people could it be? If all things being equal, we don't know anything about their grades, how many people could be the valedictorian? There's 8 of them, right? But once a person's been named valedictorian, that person will not also be salutatorian. So how many people could be salutatorian? 7. Notice we start a factorial, but we don't finish it. Because not all 8 people, we're not necessarily saying how many different ways could they end up being ranked in class order. All we care about is how many different combinations of valedictorian, salutatorian could there be? Well, obviously there could be 56 different combinations of valedictorian, salutatorian. Does that make sense? This is a permutation also, but it's a permutation of 8 possible values, but you're only choosing 2 of them. And in this is called the permutation notation. Notation refers to the way in which something's written, so this is permutation notation. It essentially uses a factorial, but it only takes the first 2 values in the permutation. So going back to that soccer team yesterday, there were 6 soccer players, they all had a race, right? Well, if we wanted to know how many different ways could all 6 of them finish, we would say that's a permutation of 6 soccer players, and we're going to put all 6 of them in different orders. Does that make sense? But what if I wanted to present ribbons to the top 3, like at field day, right? Remember your elementary days, good old days? Field day, get to race it. Well, y'all lost your last field day. Yeah. But anyway, but you get to race and throw softballs and, hop around in a bat. Well, when you were little, you get to hop around in a little burlap sack and 3-legged race, trip all over yourself. It was great, great times. You weren't here when you were little, so you never got to do the burlap sack thing. But anyway, but let's suppose we were going to give awards like field day ribbons, and we had the 6 players race. Well, when we give ribbons, we only give ribbons to first, second, and third. So of the 6 people, how many of them are going to receive an award? 3. So if I wanted to know how many different ways those 3 ribbons could be handed out, we're going to take the factorial of 6, but we're only going to use how many factors, class?
3.
Only the first 3 factors. Because there are 6 different people who could get first place. Once first place has been awarded, there are now only 5 people who could qualify for second. And once those awards have been handed out, there are only 4 people who could qualify for third place. Make sense? So you do the math in your head very quickly. How many different ways could first, second, and third be awarded? 120 different ways. And this is a permutation of 6 athletes, 3 of whom are receiving awards. Do you see how to write permutation notation, first of all? And do you how to compute permutation notation? Makes sense? I tell you, the big words here is boom. All right. All right, so look at page 378 then. I feel like I'm missing an example problem. I am missing an example problem. Back to page 376. Back to page 376. So you see that, I think they actually have the soccer players finishing first, second, third. You see that 6-5-4 thing like the next to last line on page 376. Over to page 377. You see it written out with the permutations here. 6 soccer players is N. N refers to the number of athletes or the number of people involved or the number of total choices. R refers to the sample that's being selected. So the permutation notation, in fact, some calculators have this actually built in. In Algebra 2, I'll show you how to use a special calculator to calculate this. But you'll see this button on a calculator, NPR, that doesn't mean National Public Radio, okay? NPR means this number of things taken a permutation of R at a time. But, so you see there, the N is the 6 soccer players, the R is the 3 people who are going to win something. So the notation is 6P3. And of course, as we said before, that's 6 times 5 times 4, the first 3 factors in the factorial, giving you 120 possible permutations. Look at letter A in the example box. We have a permutation of 5 whatevers, we don't know what it is, but 5 whatevers, and only 2 of them are going to be taken or selected. How many different orders could we have? Well, first of all, it's important to note that the 5 is in the position of the N. Right? There's a total of 5. N is the total number. R represents the number that are being taken from the group. That's 2. So we're going to start with 5 factorial, but we're only going to use the first 2 factors, which would be 5 times 4, which gives us 20. Make sense? Here we go. Letter B. Go ahead and read this for us if you would, Scott.
In the 8th grade class, 31st students, the student will be selected for each class office. President, vice president, treasurer, and secretary. How many possibilities are there for class?
All right, this is actually pretty true to form to what I had in 8th grade. Our classes were about 30 to 35 students. There were about 4 different 8th grade classes at my school. And we would have a president, vice president, treasurer, and secretary. Now, what the point of all those officers was, nobody really knew. But, you know, it's cool to say you had a class office and, you know, so have elections and that kind of thing. And by the time you got to like junior and senior year, you're actually doing something if you were an officer. But anyway, so first of all, how would we write the notation? Well, we're going to choose how many different ways in which we could arrange or take these items, correct, or these people. So we're going to take a permutation. We're going to start with our N, which is the total number in the group class.
30.
And 4 of them are going to be chosen for class office. So the R is 4. How do I work out the permutation? Well, start by taking
34
times,
33
times,
32
times,
39.
and then I stop, don't I? And if we multiply all of that out, and you hope you don't get a problem like this on a quiz or test, right? Yeah. But if you did, it would come out to 1,113,024. So, in other words, if you knew nothing about the students in the class, you were just given their names, and you're like, okay, I bet so-and-so's going to be the president, so-and-so's going to be the vice president, this person's going to be the secretary, and this person's going to be the treasurer. You have a 1 in 1,113,024 chance of being right. In other words, you probably ain't going to guess it. Now, if you actually knew the students, you might be like, I really think this person is probably going to be president. Probably this person will be vice president. I could definitely see them voting this person for secretary and this person for... If you knew the students, you'd be able to make a more educated guess, I suppose. But it does cause one to think twice about, for instance, gambling. The odds are never in your favor. Just don't do it. It's a waste of money, right? It's important, too, on that note of gambling. You different people, even Christians, will differ. Okay, what's gambling, what's not? A basic rule of thumb is to remember this. The money that you have, who gave it to you? No?
No.
God. You say, no, Mr. Dasky, Grace Christian School pays your salary. Well, only because I'm able to come work, right? It's by the grace of God I'm not in the hospital, laid up, unable to do anything, right? It's by God's sustaining grace He's seen fit to allow me to still be here, right? He could at any moment say, you know what, I'm ready to take you home, and I could just be gone. Or He could withdraw that favor for whatever reason. I don't understand the mind of God, and now I couldn't do this anymore. So really, truly, we have to remember everything we have is because of God. And God has entrusted the money we have to steward, right? Is it wise stewardship to risk God's money that He's given me on gambling? I don't believe so. So I don't recommend gambling or taking risky ventures that are foolish or get-rich-quick schemes. What does the Bible say? He that followeth after vain persons shall be in want. Right? He that follows after get-rich-quick, here's a way to make a lot of money. You're not going to be well provided for. But he that laboreth with his hands, he that works hard, God's going to provide your needs. So anyway, but just pointing out, I mean, that's a rather small sample. Isn't it? 34 kids is not a huge class. It's only 4 officers to get right, and there's still over 1 in a million chance that you'd actually even get, right? So in general, stay away from gambling. That's one lesson we can take away from this, speaking of odds and things of that nature. Go and turn over now to page 378. And let's take a look at numbers 11 through 15. I want you to use permutation notation to show how we would write this. So we're not actually solving, we're just writing it with the permutation notation. The whole P thing with the 2 numbers. So do numbers 11 through 15 there at your seats. All right, number 11. You see 16 times 15 times 14. Apparently that's a permutation. What is the N here, Scott? Apparently there were 16 of something, and we're going to take what are? 3 of them. Makes sense? We're taking the first 3 out of 16 items. What about number 12? How would I write that in permutation notation, Lana?
25P5.
Good, 25, capital P5. What about number 13? Joshua?
48, capital P2.
Good, 48, capital P2. Number 14, the number of ways 7 out of 30 students could be arranged. 30P7. How about number 15, Lana? The number of ways 3 out of 5 colors could be arranged.
5P3.
Good, 5P3. You got the hang of all of that? Easy enough? All right. Now I want you to do numbers 16 through 18, just expanding out and then multiplying these permutations. So calculate the value of each of those 3 permutations, 16, 17, and 18. right, number 16. A permutation of 11 items, take 4 in any order, gives you how many different arrangements? Joshua?
7,920.
Good. 7,920 is correct. How about a permutation of 8 objects, take 5 in any order? Scott? Oh, Lana?
40,320. That's what I got.
No, Scott?
Remember, he said he could.
I thought it was done already. Come on, hurry up. You're just a 4. It's one digit. Come on, man. I'm sorry?
6,720.
See, I knew he had it. 6,720.
How did you get
Well, it should be
that?
8 times 7 times 6 times 5 times 4.
Yeah, that's what I did.
Yeah, all right, so let me show you how I would do it. I don't know if this is maybe the way you did it already. So 6, 5, 4. I'd start with these two numbers because they're easiest to get 20. Times 6 is 120. Times 7 is 840. And now I just have one hard multiplication. Like this I can do in my head. That I can do in my head. Even that I can pretty much do in my head. And then this one is the one that's worked out that way. So I always start with the little numbers because they're quicker and easier.
This one.
Yeah. All right.
I messed up.
That's okay. Number 18 for redemption then, Lana. What did you get on 18?
210.
What?
What?
Did you multiply?
14 times 30. No, I put 50.
14 times
I'm
13.
trying to work too fast.
It's okay. All right. And so Scott was also in need of some redemption. 182 should be our answer there on number 18. Let's suppose that we'll come back to Lana here, just give her a chance at redemption. Lana, let's suppose you were a captain of a soccer team in PE.
182.
182 should have been your answer. Let's suppose you're the captain of a soccer team in PE, Lana, and let's suppose there are 13 students in the PE class. And you get to pick, besides you, okay? And the other captain. So I guess there's 15. But there's 13 students in the PE class beside, well, let's be realistic. We have 13 in our PE class. 2 of them are you and the other captain, right? So there's 11 students you could choose from, okay? And let's suppose you're going to end up being able to pick 5 of them to be on your team. And you're going to have to pick different positions for each of the 5. One's going to be goalie. One's going to be, main striker. One's going to be assisting forward. One's going to be your midfielder. One's going to be your defender, right? So of the 11 students, you're going to pick 5 people and put them in exactly specific positions. How many different ways could you put those students, their classmates, into their different positions as their soccer captain? All of you working it, but Lana's going to give us the answer. 11 people in the class, and you're going to pick 5 of them to be on your team, and you're going to have to assign them to different positions. How many different ways could you put together your soccer team? And this is going to make being a captain seem a whole lot harder all of a sudden, isn't it? So many choices. Well, how many are there? But I could put him here and her there, but if I did that to this person, then I could put that. So many choices to make. How many choices are there? You finished? That was quick. All right, how do we write it first of all?
11 times 10 times 9 times 8 times 7.
Right, 11 p5, which is 11,
Yeah.
10, 9, that's a 9, 8, 7, all right? And I might do this. I might multiply all 3 of these together first, because 9 and 11 is simply 99 times 0, or 10, excuse me, is 990. And then I would do that times 56, so at least I get the same digits over and over, something like that. Anyway, I actually don't know the answer, so I'm going to have to find it real quick myself. And Lonnie, what did you get for your answer?
55,440.
Good, 55,440. You just got it faster than I did. Good job. Is that what you guys got?
Yeah,
All right, so
I just went back to the number 16 and then multiplied by 7.
oh, I forgot we've done 60. Oh, there you go. Hey, I like it. Bravo, bravo. Outsmarting me at my own game. Good. I like the laziness there, Lana. So, guys who just came in, we were saying that if a captain in PE had 11 kids in the class he could pick to be on his team, and he was going to end up with 5 of them, and he had to figure out what positions he was going to put them all in. There's 55,440 different ways he could arrange any 5 players he picks on his team, which makes being a captain really complicated to think through all that. Now, that's if you didn't know anything about anyone's skill set, but that's a whole lot of different ways you could arrange athletes on your team. So, just saying. All right, number 19. Number 19, a newspaper editor doesn't have quite as hard of a job. Read number 19 for us, Scott.
The newspaper editor must choose 3 articles for the front page of his paper. One for the top, one for the bottom left, and one for the bottom right. If 21 articles were submitted, how many possibilities are there for the front page?
Alright, now this assumes these are all 21 good articles and none he's like shred this one. Okay, so 21 good articles submitted. He's going to pick any 3 and where to put them on the page. So not just 3 make it to the front page, but which one gets the main spot, which one gets this corner, which one gets that corner. How many different ways could he put the 3 articles on the page? That's the question. And Scott, how do you write it in permutation notation first?
21p3.
Good, 21p3, which is 21 times 20 times 19, which is?
7,980.
7,980 different ways he could arrange any 3 articles from those 21 he's choosing. All right, number 20. Did you get that?
No. I did 21 times 21 times 21 instead of 21.
Yeah, remember, it's descending. All right, Lana, I saw you erasing something.
No, I didn't get it wrong. I was
Just erasing some extra work to make space. Okay. 7,980, 21 times 20 times 19. Number 20, the 8th grade basketball team has 13 players on the team already, and the coach is going to pick 5 to start. Now, this is like my school growing up. Okay, we had like 100-something 8th graders, so 13 would be picked to play on the basketball team. But he's going to pick 5 to start. Now, understand, if you just pick 5 and these 5 are going to start, that's one decision. But not only is he going to pick the 5 to start, he's going to pick where to start them. So he might be like, I want this guy to start, but I could put him at power forward, or I could put him at center, or I could put him at point guard. Like, where do I put him, right? So there's all these decisions the coach has to make. With 13 guys on the team, 5 of whom are going to start, and he has to decide where to start them, in what positions. How many different possibilities are there for the starting lineup? Problem 20. This is going to make Lana's job seem like nothing. Lana's job of picking those 55,440 different ways to arrange your soccer team. This coach has a much harder task ahead of him, apparently. At least statistically speaking, he does. All right, in permutation notation, how would we write this, Lana?
13p5.
13p5, which means 13 times 12 times 11 times 10 times 9. Do you have it, Joshua?
Almost.
All right.
154,446.
I think that's a 0 at the end. 154,440 would be correct. 154,440. Did you get those answers?
It's just that my 0 kind of looked like a
All right, so we're doing wise, right? I'll make sure on quizzes and tests at least. No, you were kind of hurrying just now. But on quiz and tests, make sure you write real neatly, so I don't think it's a 6 and mark it wrong. Did we get those answers? Or did you get that answer? Excellent. Any questions on permutations? Do we feel like we got this down pretty well? All right, let's turn over to page 380. Page 380. And now let's talk through the first several questions. Number 1 says, give the name for the group that includes all outcomes that do not satisfy an event. Class? The complement.
Oh.
The complement. All outcomes that do not satisfy an event. Number 2, express the probability of an event that is certain to happen, but express it as a percent. 100%. If you know something's going to happen, it's 100% probability. In probability notation, how would we write the probability of winning a game? Lana?
P parentheses winning.
Good. Or if I'm lazy, P parentheses win, right? Probability of getting a win, or P parentheses winning. What about the probability of getting a 100% on the final exam? Scott? Good. P parentheses 100. Or P parentheses A plus maybe, but well, I guess technically a 97 here is an A plus. I'm just kind of going over these with you. Number 4, write each of the following as a factorial. Letter A, how would you write that as a factorial? Joshua?
7 factorial.
It's 7 factorial with a little exclamation point. What about letter B, Lana?
2 exclamation.
All right, 2 with the exclamation point, and letter C, Scott? 1 exclamation point. Kind of a lame one. All right, now at your seats, I want you to find the value of those factorials for A, B, and C, number 5. Go ahead and find the values of the factorials for A, B, and C, and use Lana's shortcut there on part B. Number 5, A, B, C. Find the values of those factorials, but use a bit of a shortcut that Lana, similar to what Lana would have used a few minutes ago on me. All right, letter A, 5 factorial. What do you get for your answer on that one, Joshua?
120.
120. That's pretty easy. 5 times 4 times 3 times 2 times 1. Again, the 5 times 4 is 20. 3 times 2 times 1 is 6. 6 times 120, or 6 times 20, 120. Now the 8 factorial. I'm a bit of a cheater. And I flipped back a page and I realized that last night's homework had 7 factorial, right? So if I take that, pull a Lana, and just multiply by the 8, which, again, I know you can't do that on a quiz or test, but, you know. Unless you, or maybe you take the 5 factorial you just did and multiply by 6, 7, and then 8. What do you get for letter B, Lana?
40,320.
Good, 40,320. And then 3 factorial, Scott, is just 6. Good, number 6. Express each of the following using permutation notations. How would I write out letter A as a permutation, Scott?
9p5.
Good, 9p5. Not because it ends on a 5, but because there are 5 numbers there, right? So letter B, Lana, how would I write that? Glad I don't have to multiply it.
77p2.
Good, 77p2. 77 things, you're picking the first 2, or any 2 of them. And then the letter C, Joshua?
101p4.
Good, 101p4. Number 7, write out the 12p3 as a product of decreasing factors and then multiply it out. So we're going to write it out and then find the answer for number 7. How do we write out 12p3, Joshua?
12 times 11 times 10.
Good. Well, we already know 12 times 11 is...
121.
Oh.
Oh, wait.
That's 11 times 11. 11 times 12 should have been, thank you, hey, Hayden behind, he's going 132. 132, and then stick a 0 on the end for multiplying by 10, 1,320. Multiplication shouldn't have been too bad there. Questions on those? I will be reviewing some more in our next lesson. For homework this evening, though, I want you to do page 379, numbers 13 through 21. Page 379, numbers 13 through 21. All right, have a wonderful rest of your day. You are dismissed.